Hello, this is Miss Peachy from WCA Earth Science class, and today I'm doing a little video tutorial to help you figure out how to do your first portfolio. So your first portfolio is on star composition, and here I am in Unit 2, Lesson 8, and this is the intro page, which you can see. You're probably clicked on it right now because the video that you're watching is on the intro page. There is also a link to a Google Doc here, and I would recommend using this Google Doc to do your work because it's going to be easier to use than the PDF that they've included later on in the lesson. Sometimes those PDFs can be kind of tricky, and when you use them, you put a bunch of stuff in, you type all your answers in, and for some reason the typed answers don't save in the PDFs. So highly recommend using this instead. So let's go ahead and click on that. It's going to open up this Google Doc. Now, if you're familiar at all with Google Docs, you kind of know what to do here. But if you're not familiar with them, um, you won't be able to type directly into this document because this is my copy of the document. So you need to make your own copy of the document. So you're going to go to File, and you're going to go to Make a Copy, and then you can save your new copy. And when you do that, then you can edit this copy. You can add all your answers into it. And when you're all done, you can download and save this as a Microsoft Word file, which I will show you how to do in a little bit. So let's go back to the lesson real quick. I'm going to start this lesson. And what you're going to be doing is we are going to be looking at stars in the constellation Orion, and we are going to be analyzing those stars based on what's known as their stellar spectra to be able to see what the stars are made out of. Because what's really cool is that just by looking at the light from the stars, we can determine the elements that are found within those stars because we know something about how elements behave. So stars are made up of gas, and those gases are heated, and when they are heated, they produce light. And when you look at that light through a special instrument known as a spectroscope, or you'll be able to actually see the component colors those lights are made up of. So let's look at what that looks like. So this is this is a spectrum. This is what the sunlight spectrum looks like. These are spectrums of different elements. Every element produces bright lines at particular wavelengths. So Li is the element lithium. I'm going to go ahead and make this bigger so we can see this a little bit easier. But Li is the element lithium. And as you can see, the element lithium produces a bright orange line just above 600 nanometers and at around around 675 nanometers, right? So two bright lines, an orange and a red. The element sodium produces one bright line, a yellow line here just below 600 nanometers. The element potassium only produces a purple line way over here around 400 and some nanometers. Calcium spectrum is a bit more complex. There's more bright lines. Strontium is as well, and so is barium. But every element produces its own unique signature. We kind of think of it as the fingerprint for that element. So if we look at a star and we see specific bright lines, we can then see what elements that star is comprised of. Even looking at this stellar spectrum, for example, notice this bright line right here, which corresponds to this bright line as well. So we can kind of see some overlap. And we'll be looking at how we use this in the lab investigation to determine the identification of the elements that are found in there. So you're going to click on this emission spectra lab activity. You do not need to click on the spectroscopy's tool lab report. That's what this is. That was what we actually made a copy of that I gave you a bit earlier in a Google Doc because it's easier to work with. So let's open up the lab. All right, so it talks about, how every element is unique, just like a fingerprint. Actually need to zoom out on this, otherwise it doesn't let me. And we're going to click continue. Apparently dogs have unique prints on their noses as well. And we're going to keep continuing as you read through this. I'm going to let you read through that on your own. Then we get to this, and it looks at the electromagnetic spectrum. And it says here, the emission spectrum is a spectrum of frequencies of electromagnetic radiation emitted by an element during its transition from a high energy state to a low energy state. And we'll talk more about how light is emitted with stellar spectra in class. If you come to a live lesson, we'll kind of talk about that too. But here we can see here is our low energy of 700 nanometers and our high energy of 400 nanometers. And you might think to yourself, Miss Peachy, number is higher, it's 700, and this number is lower, it's 400. But even though the numbers here actually correspond to the length of the wave. So this is a long wave. Oops. And this is a short wave, right? The shorter the wavelength, the higher the amount of energy. Every wavelength is kind of like every crest of the wavelength, think of it as like a little punch of energy. And if they're shorter together, you're getting punched with energy more frequently than you would if the crests are farther apart, which they are with longer wavelengths. So we can kind of see the color spectrum here as it relates to what we're familiar with. All right. I'm going to click on Learn More. And now you've got an activity here where you can actually look at the different elements and their wavelength. So let's go to our copy, shall we? Let's start reading what you need to do. It says use this worksheet as you complete parts 1 and 2 of the spectroscopy tool lab. In part 1, emission spectra, you will investigate light patterns produced by elements. In part 2, stellar spectra, you will analyze emission and absorption spectra of stars to draw conclusions about their composition. So it gives you a little bit of background, which again I will ask you to read on your own. So now it says in the emission tool spectra, select the element to see its emission spectrum. So that's what we're doing here. So you're going to put the element symbol, the atomic number, the lowest wavelength spectrum, the highest wavelength spectrum, and the total number of lines. And you'll complete this data table. So if we go back to our investigation, we can go to hydrogen and we can click view data, right? And all the information here. Hydrogen has H as its chemical symbol. So we can put that in here. Its atomic number is number 1. That's what that little number references is its atomic number. So I'll put the atomic number of 1. Oops, of 1. The lowest wavelength looks like it's right around 400 nanometers. So we're going to be estimating a bit here. It looks like it's, around 400 nanometers. That's what I would say. It's pretty much spot on. The highest wavelength, if I look here, well, if this is 5, 6, and 7, it's a little over halfway between 6 and 7. So I'm going to go with about 660. But again, that's an estimation. It's really going to be, estimate to the nearest 10 on that one, okay? So I'm going to go with 660. And the total number of spectral lines, we have 1, 2, 3, and 4. Okay. So that's what you're going to do with the lab tool. You're going to complete this data table for the rest of those elements. Okay, so then after you've completed the data table, you're going to kind of go back and answer a question from previous. So your mission here is to determine what gas is leaking from this I think it's a refrigerator company or something like that. What does it say? Oh, it's leaking into the lab. It's a bulb company, a light bulb company. This is the spectrum of the gas that is leaking. So you're going to compare this spectrum to all the ones you analyzed and determine which one looks like that. Which one of these looks like this? And you'll come up with an identification of that gas. And that is the answer that you're going to put right here under analyze. Then there's some questions that goes with it. In the emission spectra tool, a table shows the ranges for wavelength, frequency, and photon energy for different colors of light. What color of light is associated with the highest energy? We kind of talked about that already, right? How does this relate to flame color on a stove? So if you are familiar with a gas stove or even a campfire, if you think about what color of fire flame is the hottest, that would go along with the question for number 5. So you're going to be looking at wavelength and energy. Okay. Again, we talked about that a couple of minutes ago. Remember that shorter wavelength is higher energy and longer wavelength is lower energy. Question 6, using your data table, compare atomic number with total number of spectral lines. Is there a pattern? Does the atomic number, or do we have more lines with a greater number on the atomic numbers? Do we have more lines with a smaller number on atomic number? That kind of thing. Number 7, using your data, compare atomic number with lowest and highest wavelengths in spectrum. Is there a pattern? And then we get to part 2, stellar spectra. So now you're going to be comparing. This one you don't need to actually use anymore the tool in the lab itself. You're going to be using this picture here. So we have our known spectra: hydrogen, helium, sodium, calcium, and mercury. And each place you see a dark line is where those lines would be here. Okay, so it's kind of like looking at the opposite image. And then you have our mystery stars. So mystery star number 1 contains more than one of these elements. So match up the lines and determine which elements are found in mystery star number 1. So star name, mystery star number 1. Does it contain hydrogen, helium, sodium, calcium, mercury? You need to make check marks or X's in the box here to determine if you think it contains those elements. And then you will answer these analyze and conclusion questions here, okay? So that is the extent of what you're going to be doing for this portfolio. That's how you use the tool, and that's how you use the picture that's found in the lab. Once you're finished with this and you have it all done, then you're going to go to File, you're going to go to Download. You're going to download it as a Microsoft Word file to your computer. Make sure you save it on your computer, and then you can upload that to the Dropbox to give to me. So that's how I will get that. So if you have questions on this, let me know. Hopefully that gives you a good overview of how to get started on it. And again, if something becomes confusing on how to read some of these, please reach out to me via webmail. You can call me at school and we will set up a meeting to go through it together. But otherwise, guys, good luck. I think it should go well. And have a wonderful day.